Morning once again. This is group 9 and I'm by the names of Marie Chantal Nyirahabimana with reg number 223010-226. Thank you.
Thank you. My name is Omahora Adeline. I'm group member of this group 6. My reg number is 2230268665. Thank you.
Thank you. My name is Gervais Iragoha. I'm one of member of this group with reg number 223017118.
Thank you. My name is Christopher Musabirema with reg number 2230268832. I'm also included in this group.
Thank you. I'm Damascene Biziyaremye with 223009021 as my registration number.
Thank you. Our task was to talk about different strategies that can be used to teach some concept of electrodynamics. For us, we have chosen to use 5E's instructional model, and within it, there is the use of simulation and demonstration, even the group activity. Then we are going to talk about for us, I'm requesting you to observe this picture and you tell me what comes in your mind by observing it. Observe it. Who can tell me what comes in his or her mind once he or she observes that picture? Vanessa?
I'm saying that it is reflection of light diagram.
You may clap for her. Another one. Yes, Paspi.
Thank you. I'm seeing the arrows which are moving in different directions.
Snaps to him. Okay, thank you very much. At the end of this session, since our session is going to deal with laws of reflection and transmission at oblique instant, and the learning objective of this, at the end you will be able to identify 3 fundamental laws of optics. Yes? Make sure that at the end you will be able to drive and identify them. Yes? By observing the pictures you have seen, we have seen the incident wave. You may go back to the picture. This is the incident wave, which is hitting at this plane of incident. This is also reflected wave, and this is the transmitted wave. And you can see that we have 2 medium. This is the medium 1, and we have medium 2. And in medium 1, we have 2 waves, the incident one and reflected one. Then you go back to the table. For this one, here we have the incident wave. It's electric and magnetic. And we have reflected wave. It's electric and magnetic, even for transmitted. Yes? Continue. Yes, by observing those waves, you have seen that all waves, they have the same angular frequency, which is given by K and V. Yes? For medium 1, we have seen that this is K for incident. This is V representing the speed of light in medium 1, which may be equal to K, the wave number for reflected, and this one is also in medium 1, which may be equal to wave number for transmitted and V for transmitted, which is V2 in medium 2. And this is equal to angular. Yes? By equalizing this one with this one, we can see that K1 V1, which is equal to KT V2. And by first analyzing how we can represent this one using the refractive index. You know that refractive index is equal to the speed of light with the speed of the medium. Yes? In medium 1, it may be equal to this one. In medium 2, it may be equal to C over V2. By replacing with this one, we will get that equation that we have K1, which is N1 over N2 and KT. Then also by applying the boundary condition, continue, you will see that if you combine the wave for the waves in medium 1, both incident and reflected, and equalizing it with the wave in medium 2, yes, you will see that by equalizing the exponential factors, Ki dot R is equal to K R, which is equal to KT R. Yes? And this Ki has this component Kix plus Kiy plus Kiz. Yes? Even KR has KRx, KR1 plus KRz. Even for KT, we have KTx plus KTy plus KTz. But our boundary condition is saying that this Z is not included. This must be equal to Z. And we remain with this one. And you know that the component of R is X component plus Y plus Z. Yes? Even this one is not included. If we try to do this one, you will see this equation. Yes? Then by also letting X equal to 0, you will have this one. Even for Y equal to 0, you will get this one. Yes? Yes. Finally, continue. The next slide. You will see that one. Coming back to our diagram, we have seen that this is the incident wave, yes? And it is forming its angle of incidence. And this one is reflected with its angle of refraction. No, reflection, yes? And if we form this one as right triangle, you can see that how can you go to that angle of incidence? Using the Pythagoras theorem, how can you get that angle of incidence? Yes, then go and show us.
Thank you. The angle of incident is equal to this side, which let's call this side A over the wave number of this incident. This is a sign of the sign of this angle. Then angle of incident is equal to sine inverse of A over wave number of incident sign inverse.
Clap for BNM. Thank you. Since this one is X and this one is Z, you can see that if we project this one here, you can have KIX. Yes? And you see that the sine of theta, angle of incident, is equal to opposite side, which is KIX over what? Hypotenuse, which is KI. Yes? And KIX is equal to KI sine of angle of incident. And if you do it on this one for reflection and this one for transmission, you will get that one. And that is the first law of reflection, which is saying that incident wave and the reflected wave and the transmitted wave all form what? A common plane. Yes? That is the first fundamental law of optics. Thank you. Let me welcome another one to continue with playing. No, we will showing you an assimilation explaining it more clearly. Thank you.
Thank you. Let's continue for explaining more about the reflection of wave. Okay, let me use this simulation for more explanation. This is a wave. This is incident wave, reflected wave, and transmitted wave. When I come here and we have two medium. We have medium, upper medium, which is air, and lower medium, which is water. When I come here and increase the index of air here, when increase index of air, our reflected wave move toward the normal. When I come here and change the index of diffracted wave, when I increase index, our refracted wave move away from normal. Means that this wave, incident, diffracted, and transmitted wave are governed by number of index or value of index. Thank you. Later welcome another member to continue.
So thank you. We have seen a lot of things. We have seen the first law. That is why we are going to do the second one, the second law. So I would like to request you to sit in a group of 4 and try to drive the second law of repetition and Snell's law for reflection. So So I'm going to use the at most 2 minutes. At most 2 minutes. You are done? Wait for others. Yes. Okay. Who want to present? Anyone? Are you done? Is it complicated or not? Okay.
The question was instead about the role of reflection. The first one said that the incident okay. The question was to state about the laws of reflection, which is the second law of reflection and the Sine's law for refraction. The answer is that the incident ray, reflection ray, and transmitted all lie on the same plane. Thank you. Okay, that's the first one. The second one, the second law of refraction is about the Sine's law. Okay. It's stated that the angle of incident is equal to the angle of the ratio of angle of incidence is equal to the angle of ratio of the angle of transmitted. Thank you.
Thank you. Let us back on the simulation a little bit. Let us back a little bit on the simulation. Okay. Remember, we are dealing with waves, not rays. Yes. So that is the incidence one, and what transmitted is this one, and this is what is the reflected. So what is rho, which is in this area, the upper part? Yes.
I can say that the law in upper part is the law which is the law of reflection, which says that angle of incidence equal to the angle of reflection.
Okay, thank you. That is the second one, the second equation, the second law. The first one was all these, the incidents, reflected and what transmitted occur in the same plane. So I was asking to derive the second one, angle of incidence equal to the angle of, that was the question. May you repeat in your respective groups? Try to derive it. And remember, we are dealing with waves. This one, you can represent it as the electric field, which is incidented, which is equal to, this is an amplitude on incidented one, exponentially I, then K, R, negative W, T. And for reflected, can be represented by, this is amplitude, R, then E, R, then K, this is I, R, then R, negative W, T. You can use this to derive. Right.
Thank you. From the second row, we have seen that K incident equal sine angle of incident equal K reflected sine angle reflected. If K incident equal K reflected, means that sine angle of incident equals sine angle of reflected. Thank you.
Okay, thank you. And that means if sine this angle, which is inspected, and sine, which is equal to sine theta r, that means theta r equal to theta r, and that is the second law of reflection. Okay. And that these are expected answers. That is the first one. I've seen it. The second one also I've seen it. The third one, which is Snell's law, I've seen it. So thank you. Let me call upon another presenter to continue.
Okay, let's continue our session. Let's take a look on some more application of the laws of reflection and transmission at oblique incidence. Before we outline those application of the laws of reflection and transmission, I want to ask someone who can tell me at least one application of law of reflection and transmission. Who can try? I think you can say one application of this reflection and refraction laws. You can say a mirror. When you are seeing your face in the glass, it is one application of that concept. Thank you. Another one.
Thank you. The law of reflection can be used in real life. especially when we go to the hospital or health centers. They can use this law in medical imaging to see inside our body, and what they see inside can be reflected back, and they can be able to diagnose the patient at the health centers. Thank you.
Claire.
Thank you. Another law of reflection and diffraction. It is used in periscope. You know, periscope is a device that submarines use when they are underground in the sea to measure the distance from Earth. From the sea level up to down. So they use a law of reflection to measure that distance from, to measure the distance from the above sea level or to measure the depth of the ocean. Thank you.
Thank you. Clap for them. As they said, here are some more applications of the laws of reflection and transmission. It is used in optical devices and instruments, in mirrors, periscopes, as they said. Also used on lenses and reflection, eyeglasses and contact lenses, cameras and microscopes. Also used on projectors. Also, the laws of reflection and transmission at oblique incidence are applied in medical and scientific uses, in X-ray imaging, laser surgery, and spectrometers. So those are some applications. There are so many. Those are some applications of laws of reflection and transmission at oblique incidence. Thank you. Let's welcome Mr. Christoph to continue.
Thank you. I'm also Christopher Musabirema with reg number 22 30 26 832. Then we have studied laws of fundamental of geometric optical. We are going to look at them. We have three fundamental laws. First one is wave incident number sin theta 1 is equal to wave reflected number sin theta I is equal to wave transmitted number sin theta transmitted. The second law is second law of reflection, which is theta incident angle of state is equal to angle of reflected. We have to know that this came from where? We know that in some media, K incidence will go to K of reflected. Okay? This means that K is equal to sin theta 1 is equal to K L sin theta L. This means that we have to simplify by K1. See that sin theta incident is equal to sin theta reflected. This means that angle of incidence wave number is equal to angle of reflected wave now. I think it is proven. The third one is equal to sine is sinel is law. Sine of angle of transmitted. Are you getting me? Yes. Over sine instead angle is equal to N1 over N2. This is the third law, fundamental of geometric laws. Before moving to the quiz, who can summarize what you have studied today? Who can summarize? You.
Yes, we have seen the laws of reflection. The first one tells us about how the angle of incidence and the angle of reflection are equal. The second one is the Snell's law. Thank you.
Take a sheet of paper, then we do a quiz with 5 minutes. Who can read the question number 1? Who can read?
Teach.
You.
Write 3 fundamental laws of geometrical optics.
Who can read the second one? You.
Explain one application of reflection and transmission and optical incidence.
Do it quickly.
Yes. Yeah, done.
Let us collect. Okay. Take your paper. Who has 10 over 10? Clap for them. Thank you. Let us invite another member to conclude.
Thank you very much. This was the end of, no, this was the presentation of Group 9, and we was talking about the laws of diffraction and transmission at the oblique incident. And I hope that everyone know how to drive the 3 fundamental laws of geometrical optics.
Yes.
Thank you. See you next session.
Thank you.